Hey guys, welcome back to another video. So here we need to prove the following trigonometric identity. So before we do this video, we need to make sure that we have complete knowledge on trigonometry at least, and at least all the identities. So first things first, looking at the expression, we have sin 2x here and we have a cos 2x. So we need to know our double angle properties, okay? So just a quick note, what are double angles? So we can say that sin 2x itself can be expanded to 2 times the sin x multiplied by cos x, okay? So two lots of them. Whereas cos 2x can be expanded in multiple ways. So we'll leave it as is. Actually, to put the more general expression, it's just the difference between cos squared x and sin squared x. But these can be rearranged, of course, based on the sin squared plus cos squared rule. Now, one useful trick I recommend for any proving system is to always convert every single term here to sines and coses, yeah? I'll show you why in the end. So right at the bottom here, I would always do a triple equal sign. And on the left hand side, I'll convert to sine cos, and the right sine cos. So let's look at the right. Tan x, we know it should always be is the same as sine x over cos x. Cos 2x, again, could be anything, but we're going to stick with cos squared version, yeah? Just for the time being. So until we can see where we're going with the left hand side. Now on the left hand side, if we expanded this, so sin 2x only has one definition, thankfully, so it'll be 2 sin x cos x minus tan x would be sin x over cos x. Okay, so far so good. So hopefully my handwriting improves. Now let's have a go, yeah? What do we have here? So let's move on to the very first step here. So we can continue with the step we did here on the very first step. So this can therefore be exactly as written, 2 sin x cos x minus sin x over cos x. Now notice how they combined every term. So let's combine the terms. So we need to realize that everything is over cos here. So perhaps we need to multiply up and down on the first term here. There's 2 sin x by cos up and down. So we should have 2 sin x cos x, because there's an extra cos x, it'd be cos x squared all over cos x. And now minus sin x over cos x. Alright, not so bad so far. Okay, so next thing, what's going to be next? So now we can combine the terms here. So everything will be over cos x. So we're going to have 2 sin x cos squared x minus sin x all over, give me a second, oh god, it's hard to do that, cos x. Now before we get to this last step here, we need to observe. So here they somehow go cos squared minus sin squared. So looking over here, let's factorize the sin x for now. Okay, because sin x seems to be outside the bracket with cos x. So factorizing sin x, what do we get? So we get 2. No, we don't. So we get sin x outside. Inside the bracket, we're left with 2 times cos squared x minus 1. Okay, excellent. Now, we've actually got a solution. So one thing to know, one of the other equations for cos 2x is this. So we got cos squared x minus sin squared x. If we let sin squared become 1 minus cos squared, we will actually get 2 cos squared x minus 1. So yes, guys, this term right here is actually cos 2x. And that's it, we've proven it. And then we can finally say, therefore, this would become this term. And finally, this can be rearranged to be tan x cos 2x. And that's it, guys. This is my shortcut done. So recap, always convert everything into sines and cosines, yeah? Always convert them sines and cos, because the reason why this will make your life a hell of a lot easy. But anyway, that's it for now, and I'll see you on part B. Okay, ciao.